What's up guys, welcome back to K.D.P programming, and in today's video we'll be continuing our data structure journey. In the last video we spoke about arrays, and in this video we'll be talking about queues. And if you haven't watched the previous video, I highly recommend that you watch that video first, because I'll be making references to that video. I'll put the link to that video in the description box below, or you can click on the pop-up on the screen. And one thing that I always like to point out in these videos is these videos are concept-based videos and they are not language-based videos. So what I'm doing is I'm trying to explain a certain concept. No matter if you're using a different language, you're still more likely to be fine with the concept that I'm explaining. I don't focus much into a language. If you see me demonstrating a certain concept in a certain language, maybe it's because I felt like using that language at that specific moment in time, but my more effort is spent on trying to explain the concept and trying to make you understand how the concept is used and how you can implement it in your language. So without wasting any time, let's get straight into this. A queue is actually nothing but a bunch of data stored and processed in a sequential like manner. What do I mean by that? So whenever you think of a queue, think of it as people standing in line for some service. So whoever is first in line is the first person to receive the service, and whoever comes last has to join at the back of the line and is the last person to get the service. So I have an example here on the screen. If we can just look here on the screen, I know it looks more like an array, so that's the reason why I said if you haven't watched the first video, I highly recommend that you start with that video, because everything in this video will make sense. So we have a queue here that has 8 elements, and the first element in the queue is your element 2, and the last element in the queue it's your element 9 here. So if we can look here, we have what we call the front or the head of the queue, and we have what we call here the back, tail, or rear of the queue. So what happens in a queue is data is stored and processed in a sequential like manner. So meaning whenever you store data in a queue, unlike arrays, you don't have the ability to use indexes or subscripts. Whenever you store data in a queue, it's more of you are inserting or you are pushing a new element into the queue. So I'll give you an example of how this queue actually came out to be. So the first element that you had in your queue, it's 2. So the second element that comes in, it's 3, and the other one that comes after that is 4, up until you have the last one in your queue, which is 9. So like I said, whenever you think of a queue, think of people standing in line for some service. So here are some of the things that you are more likely, or the most popular method that you are to work with when it comes to queue. You have your 3 most functions or most popular functions in the queue that we call we have your dequeue, and then you have enqueue, and last but not least you have what we call peak. So these are the most popular method that you are to deal with when you are working with queues. So what does it mean when we're talking about when you're talking about dequeue, or when we're talking about enqueue or peak? In a queue, you don't have the ability to say I want to store a certain element at a certain position. That is done with arrays. You don't have the ability to say give me a certain element at a certain position. That is done with arrays. So what happens is you have these functions. So enqueue, I'll start with enqueue. To enqueue, it means to put or to insert a certain element into a queue. So to enqueue, it's more of to push or to add, but we'll just say to add your element. And one thing that you have to take note when it comes to adding an element in your queue is whenever you add the element will always go to back of the queue, like I showed you here. So this queue started with 2, and then they added 3, but because 2 was already there, 3 came at the back of 2, and then 4, 5, 6 up until 9. To dequeue, it means to take or to give me the next element in the queue. So you have to pay attention of this. A queue has a tail and a front or a head. When you incur something, you add it to the back of the queue. But when you decure, it's more of you are removing, or if you are in line, it's that moment in time when they say next, and the next person in line goes and gets the service. So in this situation, if we were to decure this queue, the element that we will actually get or we actually receive, it's number 2. So when number 2 it's decured or it's removed, it is literally taken out. It's taken out of this queue. So number 2 does not exist anymore. So now your queue only has 3, 4 up until 9. And if you decure again, the next element that you will get, it's 3. If you decure again, so when you get 3, that element, it's taken out of the queue. It no longer exists. Your queue exists of this element now. And the next one that you have there, it's 4. And at this point, should you decide that, okay, I want to incur another element, let's say maybe I incur 10, your queue will actually start from 4, 5, 6, 7, 8, 9, and 9 is our last element. So at this point, after 9, we will have 10. So I just want you to get the difference between these two methods. To incur, it means to add or to push or to insert a new element into your queue. To decure, it means to take or to remove the next element in the queue and work with it. And I want you to just get this, because whenever I say to decure, I said when you decure and you get 2, that element is removed from your queue, and then you're left with 3. You decure, and then 3, it's removed. You decure, you're left with 4, and then 4, it's removed from that element. So now there's another method that's called pick. Well, pick works similar to decure, but it's not the same thing. So if your element or if your queue was like this, it started from 5, 6, 7, 8, 9, and it had 10, and you actually went and say, I actually want to pick this queue. So what would you get is you would get 5, because 5 is the next element in the queue. But 5, it is not removed from the queue. So it is not removed. It's not removed from the queue. So when you pick an element in the queue, it is not removed. The element is still there. It's just that you just went and checked, okay, who's next in line? It's number 5. Okay, fine. I don't want to remove it. I just wanted to check who's next in line. Should you come again and say pick at the very same queue, you will still get 5, because 5 is still there. It's not removed. So that's the difference that you have to know between your pick function and the decure function. So whenever you pick something, you're just looking for the next, element. But when you decure, you're actually taking or you're removing the next element. So you're removing the next element in your queue. That's what I want you guys to get a well understanding of. To pick, it's more of looking. To decure, it's more of taking that element and working with it and removing it from the queue. So I'll give you one last example here. So I'm sure we have all been into, maybe let's say you went to a pharmacy, or maybe you went to your license department, and then you have those little machines where you have to take a ticket, and then you go stand in a line, and then there's maybe an automated system somewhere that says now saving number 10 at counter 3, or now saving number 12 at counter 4. So sometimes what you have is, when you go to those places, you might find out that they have more than one line. They might have, maybe let's say they might have the first queue that it's only saving. Let's say you are in a license department. You might have one queue or one line that it's solely dedicated for registrations, registrations, and then we have another line that it's solely dedicated for renewals. And then what happens is you go to the little machine and then you take a ticket. So how the system is, sometimes you'll notice that when the system calls out the next ticket, the tickets are never in order. It might call out number 10 saving at counter 4, and then the next one might say number 9, or it might even jump and say number 11. So what happens is you go and take a ticket, and maybe taking a ticket for registration. So the first ticket, let's say it goes and say this is ticket number 1. Your element is stored in registration, and if someone comes for registration and takes the second ticket, and then you have ticket number 2, and then someone again comes and say I'm also in registration and takes ticket number 3, and then the fourth person comes and say I want to renew. Then they say, okay, you are queued in the renewal queue. And then the next person comes and that it's in registration. The next one comes, 6 renewal, 7 renewals, 8 renewals, and then you have 9 on registration and 10 on registration. Now, these two things here, these are two different queues. You have the registration queue and you have your renewal queue. So what happens now is, if you have, let's say maybe you have counter 1 up to 5 that works with registration, and you have counter 6 up to 10 that works with renewals. So what's going to happen is, when these counters first open, let's say maybe counter 1 will call for the first person in this line, which means they will call for ticket number 1. And that method that happens there, it's actually dequeuing. So they dequeue element number 1, and then the system will be like ticket number 1 saving at counter 1, and then this ticket, it's taking out of the queue, and then you are only left with 2, 3, 5 and 9. And then the next one comes and say ticket number 2 saving at counter 3, and then it goes and say, maybe let's say in renewals counter 7, it's now open, and then the system says counter 7, sorry, it says ticket number 4 saving at counter 7. So this is what literally happens. Sometimes just find out these two things, they are stored in two different queues, but they're actually taken out in a sequential like manner. So whichever ticket that comes first in the queue, it's the ticket that will first receive the service, and whichever ticket that comes last in the queue, it's the ticket that will receive the ticket last. So it's the ticket that will receive the service last. So this introduces a phenomenon we know as FIFO, or first in. It's FIFO like this, or so, which is first in, first out, meaning whichever element that comes first in your queue, it's the element that will receive the service first, and whichever one that comes last in your queue, it's the one that will receive the service after all the elements in your queue. This is one of those things that you should know. It's part of those what you call it, garbage in, garbage out type of thing in programming. So let's just jump into code and quickly show you how this thing looks. So here's a quick code that I actually wrote, so you can just go through this code. It's nothing major, it's super easy. So I just declared a queue, and then I pushed or enqueued some elements in there. You can see this is the same as what we had before from our whiteboard. So I have a queue of 8 elements, and it actually starts from 2 to 9. So if I just say, let me just run this so we can see how our queue looks like. So you can see there it's 2, 3, 4, 5, 6, 7, 8, 9. It's the same as we had it before. Or I could just do this. I can just do this to make it stay on one line. Let's just say I in there. Give it some space there. Let's run it. So you can see now it's 2, 3, 4, 5, 6, 7, 8, 9. Now it looks like a queue. So I'm gonna go through the methods that we were going through. So already we covered in queue. Here you can see in queue it means to add or to push an element into your queue. So if I just say numbers, this is the name of my queue, and I say in queue, let's say now we want to add our next element, which is 10, and I say 10. Now when I run this, my queue is supposed to end at 10 because I added a new element. So now if I do that, you can see after 9 we actually have 10. Now I want to show you guys the difference between decure and pick. So now if I actually go and say numbers dot decure, so what we said is when I say decure, I'm supposed to get the next element in the queue, and when we do that, we take from the head or from the front of the queue. So if I just say execute 3, 4 up until 10, this is because before this for each loop ran, we actually dequeued an element from our queue. So if we just do this to make it more simple, let's just do this. Let's put this here. Let's copy that and do that. So I want us to look at the queue before it was dequeued, and then look at the queue after it was dequeued. So if I just do that, okay, let me just make a new line here, console write line. So the queues can be on 2 different lines. So you can see that our first queue, it looks like it's the original queue before it was dequeued. So you can see start from 2 up until 10. But after that was printed, I actually went and said, hey, I want to dequeue, or I want to take the next element on the queue and work with it. Like I said, we take from the front of the queue. We actually took 2 and worked with it. So now if we do the same with pick, so if we just go and say we don't want to dequeue anymore, we just want to pick. So now when I do this, I expect the first element to print, but we'll print the original element with all the elements, nothing removed, and then I pick, and after picking I print the queue again, and I'm also supposed to, or I'm also expecting the queue to print as it is, because when I pick, I don't remove the element, I just look at it, work with it, but it's never removed from the queue. So if I just do this and say, you can see that this is our original print and this is the print after pick. So the element was picked at, but it was not removed from the queue. So to make it easy, I can just do this. Let's just say int picked number is equal to, then let's do that. Before we do this, we can just say where's our pick? Did I actually cancel the pick? I think I cancelled, oh, because it's here. Okay, so what I will do is I'll pick that and put in there, then I'll console write line, and we will say our picked element is, then we say pick number. So let's just run that. So now you can see that our queue, our original queue before I picked, it started from 2 to 10, and then we picked the first element in the queue. We stored it in this variable named pick number, and this is where we output the variable. So you can actually see it says our picked element is what? It's 2, but the element is still there in the queue. It is not removed, it's just been picked at. So when you dequeue, you remove the element from the queue, but when you pick, you just look at what is the next element and you don't remove it. And even if I do this again, let me say int second pick, I want to pick at the queue again, then I print. Even if I do this again, okay, let's just stop and run that again. Let me just put it in the next line. Let's console. Let's do that. So now you can see that I picked it. This is the original queue. I picked and I got my element of 2. I printed the queue. It's still as it is. Then I did a second pick. It still gave me 2, and then I looked, I still have 2. So no matter how many times you look, you always get the first element that is in the queue, and that element will never be removed. So that's all that I have to say about queues. So if you guys have watched this far, don't forget to subscribe and hit that like button, and I'll see you guys in the next video. So cheers.